Drifting in from the dark between the stars, there comes a visitor without a home. Astronomers call it 3I Atlas, the third interstellar object ever seen, a shard of ice and rock carrying with it the hush of uncounted light years. It does not circle our sun the way planets do. Instead, it sweeps in on a path that says, "I was born elsewhere. I will never return." What is it made of? Why does its light shimmer strangely green, as though a hidden chemistry is at work? And why now, in this brief moment of our history, does it appear at all? Some call it a comet, some whisper of stranger possibilities. To most of us, it is simply a reminder that the universe still keeps secrets. Tonight, we'll follow this wanderer as gently as if tracing a finger across a map of the unknown. Together, we'll gather what astronomers know, what dreamers imagine, and what mysteries remain unanswered. By the end, you'll have the whole story, everything you need to know about 3I Atlas without needing to chase a dozen scattered videos. And welcome back to the Sleepy Explorer, a quiet corner where the cosmos becomes a bedtime story and wonder moves at the pace of a lullaby. Before we set off, I'd love to know, where are you listening from tonight? Is it late with the room dim and quiet, perhaps only the hum of a fan or the soft glow of a lamp beside you? Share your local time if you'd like. It's always magical to see how our sleepy constellation of listeners stretches across the earth. And if this slow journey brings you even a breath of calm, you're welcome to give it a like or subscribe, only if it feels right. That way, this small ship of starlight can keep drifting, carrying new travellers into the night. So let's turn the page together and begin tonight's story. Everything you need to know about 3I Atlas, the interstellar visitor we may never see again. There are moments in astronomy when the universe feels less like a distant backdrop and more like a house with unexpected knocks at its door. For centuries, humanity looked out at the sky and assumed we knew its rhythm. The planets turned, the comets swept by in long ellipses, the stars wheeled overhead. We thought of the solar system as a self-contained stage, its actors familiar and rehearsed. But sometimes the curtain shifts. Sometimes a stranger steps in. In the late 2010 seconds and early 2020 seconds, astronomers began noticing that the cosmos was less predictable than we imagined. The first hint came in 2017, when an object called Oumuamua shot past us too fast to be from our sun, shaped in ways that defied easy classification. Then, in 2019, a second interstellar visitor, Borisov, swept in trailing a long and ordinary comet tail, but carrying with it the thrill of proof. We were not alone in space debris. The galaxy itself was reaching across to us. These weren't our comets. They were others. By the time astronomers spotted a third, the pattern had changed forever. 3I Atlas was its name, the third interstellar object, discovered by the Atlas Survey Telescope in Hawaii. Its trajectory was unmistakable, hyperbolic, meaning it came from outside, would visit briefly, and then never return. It was as if, after centuries of silence, we suddenly realized our front door had been unlocked all along, and travelers were free to come and go. What made 3I Atlas so compelling was not only that it came from beyond the sun's grasp, but the way it appeared to glow strangely. Astronomers reported chemistry that didn't quite fit the expected script. Higher amounts of carbon dioxide, hints of nickel stronger than iron, bursts of light that flared and then faded without warning. It looked familiar, like a comet, yet also slightly wrong, like a face, altered in some uncanny way. For sky watchers, this raised a cascade of questions. How many of these visitors were out there? Was our solar system simply on a cosmic highway, with travelers whizzing past every few years? Or was there something unusual about this era of history, something that made interstellar fragments more likely to be passing by now? To the public, of course, the story was even more tantalizing. Media headlines played with speculation. Was it alien technology? A mothership? A messenger carrying seeds of life? Others wondered if its path so near to Mars was more than coincidence. In the quiet hours of night, when telescopes tracked its arc against the stars, it wasn't hard to imagine it as a scout, the advanced shadow of something larger still on its way. And yet, behind the fevered speculation, the reality was also poetic in its own right. 3I Atlas was a survivor of immense time and distance, a fragment from another star's nursery, cast adrift for perhaps billions of years. To hold it in our telescopes, even briefly, was like catching sight of a message in a bottle launched from a shore so far away that the sender is long gone. We will never walk up to it, never touch its surface. Its visit is one-way, ephemeral. But in that passing, it leaves us with a choice, to either treat it as an oddity, soon forgotten, or to pause, to listen, to ask what stories such a wanderer might carry. Because every knock at the cosmic door has meaning, every stranger, however silent, is an invitation to wonder. And that is where we begin our journey, not with answers, but with the sense of being watched, or perhaps being visited. The discovery itself came quietly, as most revolutions in science do. There was no dramatic flash in the sky, no global news alert. Just a telescope in Hawaii, part of the Atlas Survey project, sweeping across the heavens in its nightly patrol for near-Earth objects. Its job was straightforward: find things that might hit us. Yet on one of those evenings, the data revealed a light that moved in a way that didn't fit the patterns of familiar comets or asteroids. At first, it was just a blip. Observers could have dismissed it as a quirk of measurement, the sort of mistake that happens when you stare at millions of faint dots across the night sky. But with each night's data, the object traced a path that curved differently, not bound to the sun, but rushing in and then out again, on a hyperbolic trajectory. The astronomers gave it a name in their catalogue, C 2019 Y4 Atlas. That long string of letters and numbers would later be remembered more poetically as 3I Atlas, the third interstellar wanderer in human history to be identified. There was something intimate in that moment, like discovering a stranger had stepped across your garden path, leaving footprints in fresh snow. For those who lived through the earlier discoveries Oumuamua and Borisov, the thrill was doubled. Once is an anomaly, twice suggests possibility. 3 times it begins to feel like a pattern. The galaxy, it seemed, was not as quiet as we once believed. Fragments from other systems really do find their way to us, little shards of other suns' histories, drifting across the great dark until gravity and chance bring them near. And as astronomers began to track 3I Atlas more closely, the questions deepened. Its brightness shifted in ways that defied prediction. Some days it seemed to flare, almost as if sighing in relief after a long journey. Other nights it dimmed unexpectedly, vanishing nearly into invisibility. Chemical signatures hinted at a composition unlike most comets catalogued in our system. To the scientific mind, this was tantalizing evidence. To the dreamer, it was a spark for myth. Imagine standing beneath the night sky as the first images came in. A faint greenish glow, not steady, but pulsing, alive with strangeness. Was it simply frozen gases boiling away as it neared the warmth of the sun? Or was it, as some headlines dared to suggest, something less natural, perhaps a vessel, shedding a disguise, revealing its true form only when no longer able to hide? Of course, scientists pushed back against such leaps. The responsible answer was that 3I Atlas was behaving like a comet, albeit an unusual one. But in those earliest nights, before models were refined and explanations given, there was space for wonder, space to lean back, look upward, and ask the timeless question, what if? And that question, whispered in the quiet of observatories and in the imaginations of countless listeners across the globe, is what turned this discovery into a story, because every comet is an object, but every interstellar visitor is a character carrying with it the drama of distance, the allure of origins, and the possibility that the universe is more crowded, more connected, than we dare to believe. As word of the discovery spread beyond observatories, 3I Atlas slipped quietly into the fabric of public imagination. News outlets ran short features, science blogs carried updates, and online forums lit up with speculation. It was easy to see why. The phrase interstellar visitor carried a weight unlike any ordinary comet. It spoke to distance and strangeness, to the idea that something utterly alien had brushed against our small domain. For some, it was a scientific curiosity, a chance to test telescopes, refine models, gather data. For others, it was fuel for wonder or for worry. On social media, theories bloomed. Perhaps it was a probe, perhaps a mothership, perhaps even a sign of doom. A few remembered how Oumuamua had once been proposed, half seriously, as alien technology. 3I Atlas seemed to invite the same whispers. Yet beneath the swirl of stories and the flurry of headlines, there was something quieter, more profound. This was not just about one object. It was about what it meant for us to suddenly recognize visitors at all. If 3 had already been spotted within a handful of years, how many had passed unnoticed before? How many still wandered through, their faint glimmers lost in the background of stars? To think of our solar system as porous open to the endless drift of galactic debris was to think of ourselves as less isolated than we once believed. Earth, Mars, Jupiter, the Sun itself, all of them, in the long run, are not walled gardens but crossroads, and every crossroads implies travellers. Astronomers watched, measured, debated, dreamers speculated, and the rest of us looked upward, wondering what it meant that a stranger had come to our door uninvited, unannounced, and already on its way out. Would we learn something in time? Would it change how we see ourselves? Or would it simply pass, leaving us a little more aware of the great currents that flow beyond our sight? 3I Atlas was never ours to keep, but even in its brief passage it reminded us that we are not alone in the night sky. That realization, humbling, thrilling, unsettling, is the true beginning of this story. And so, in the next section, we'll follow that beginning more closely, tracing the wave of asteroids and comets that seem to cluster around this moment, and asking whether it was mere coincidence or part of a larger pattern waiting to be seen. Astronomy is often imagined as a science of great discoveries announced with trumpets, dazzling images of distant galaxies, press conferences about exoplanets, front-page news when black holes are revealed. But in truth, most discoveries begin humbly, as faint dots of light, numbers in a spreadsheet, the quiet persistence of telescopes scanning the sky. So it was with 3I Atlas. Its arrival was not marked by spectacle but by the patient sweep of the Atlas Survey telescope in Hawaii. Night after night, this automated sentinel was tasked with a serious responsibility, to spot anything that might one day collide with Earth. It was meant to find threats, yet what it found instead was a messenger. On the evening of the 28th of December 2019, astronomers reviewing the data noticed a small, moving point of light. At first, it seemed unremarkable. Every night, the detectors pick up countless such specks, asteroids in their familiar orbits, comets on long ellipses, satellites gliding across the field of view. But this one traced a path that was different. Its curve, when mapped against the gravity of the Sun, revealed something startling. The orbit was hyperbolic. This was the mathematical signature of an object not bound to our star. It was rushing in from interstellar space, curving past the Sun, and heading out again, a one-way visitor. The recognition was electric. In a single night, a speck of light no wider than a pixel became a messenger from another star system. It was given the provisional name C2019Y, 4 Etlas, but soon astronomers began referring to it more simply as 3I Atlas, the third interstellar object, the third time humanity had caught one of these strangers passing through. To the scientific community, this was confirmation of a truth long suspected. Interstellar debris must be common. To the wider world, it was something more romantic, a shard of the unknown sweeping through our neighborhood like a ghost ship on black waters. For weeks, it seemed faint and easy to miss, a subtle glow against the night sky. But as astronomers trained their instruments on it, 3i Atlas began to reveal its strangeness. Unlike the many comets catalogued before, its spectrum hinted at chemistry that was unusual, higher in carbon dioxide, streaks of nickel brighter than expected, and its brightness shifted unpredictably, as if it could not decide whether to reveal itself or fade into shadow. Even before the news spread, those who studied the first images felt a quiet thrill to look at the faint green haze on a computer screen and know that it was not of this solar system, that it had wandered for perhaps billions of years from a nursery of stars far away, was to feel the immensity of space collapse into a power-connected, single, intimate moment, a reminder that the cosmos is not closed off but porous, connected, alive with motion. Astronomy is full of catalogue numbers and data tables, yet every so often a discovery escapes the page and becomes a story. 3i Atlas was such a discovery. It was not merely another comet, it was a traveller, a stranger at our door, and once people heard of it, they began to ask questions that reached far beyond orbital mechanics. What was it? Why had it come now? And most haunting of all, were we truly seeing it for the first time, or had countless others already passed unseen in the dark? In the beginning, the discovery was a story only astronomers knew how to tell. Telescopes caught the light, observatories checked the numbers, and orbital calculations traced the path. But the strangeness of 3i Atlas refused to stay confined to scientific papers. Word slipped out, as it always does, and soon the wider public was listening. What made it so captivating wasn't only the fact that it came from elsewhere, it was the timing. Humanity had just begun to digest the news of Oumuamua in 2017 and Borisov in 2019. To have yet another interstellar visitor so soon felt like the opening notes of a new pattern. If these objects had been passing through for billions of years unnoticed, why were we suddenly catching them now? For scientists, the answer was partly technical. Telescopes had grown more sensitive, surveys more comprehensive. Our eyes on the sky had sharpened. But for storytellers and dreamers, the coincidence hinted at something more. Perhaps these visitors had always been there, invisible until we were ready to notice. Perhaps their timing was not random at all. In January and February of 2020, observations multiplied. Each night, faint images were stitched together, revealing the comet's structure. The greenish glow around its nucleus caught attention, shimmering like ghostly aurora. It was not the steady behavior of a comet we knew well, but something unpredictable, shifting from bright to dim and back again. This unpredictability became a theme. Amateur astronomers reported bursts of light that didn't match forecasts. Some claimed to see fragments, as if the comet were already coming apart. To seasoned observers, this was a scientific puzzle. To the public, it became a source of speculation. Was it shedding layers like a disguise? Was something alive inside, pulsing with energy? Magazines ran features, blogs filled with theories, and slowly, 3i Atlas slipped from the realm of numbers into the realm of myth. It was no longer just a comet. It was a mirror reflecting back whatever hopes or fears people carried into the night. For some, it was a cosmic wonder, proof that the galaxy's debris touched us more often than we dared to imagine. For others, it was an omen, a shadow on the edge of our fragile world. In this way, the discovery of 3i Atlas became more than a scientific note. It became a cultural event. A whisper passed between scientists, then a ripple across headlines, then a fascination for ordinary people who might never look through a telescope but still felt the thrill of a stranger in the sky. It was not only a question of what it was, but of what it meant to us, here, now, in the brief span of human history. By the time the world began to pay attention, 3i Atlas had already become more than data points and orbital diagrams. It was a presence faint, elusive, but charged with meaning. People who had never cared about astronomy suddenly found themselves scrolling through news updates, searching for the latest images, whispering questions late at night. Part of its allure was how fragile it seemed. Unlike a planet or a long-lived star, this visitor appeared transient, already unstable. Some astronomers warned it might not last long at all, that it could fragment before reaching its closest point to the Sunday. That fragility gave it an almost human quality, a reminder that even in the vastness of space, endurance is never guaranteed. And yet, it was that very fragility that made the story shine brighter. A visitor we might never see again, perhaps even one that would not survive its passage, demanded our attention while it was here. Like a candle flickering against an endless dark, 3i Atlas reminded us that the rarest lights are often the most fleeting. To astronomers, this was a gift, a chance to measure, to compare, to enrich our understanding of interstellar objects. To the rest of us, it was a reminder that the universe is not static but alive, full of encounters waiting to happen. And in those weeks when the news carried its name, when images spread online and people looked up in curiosity, we became part of that encounter. The discovery was never about one telescope in Hawaii or a string of catalogue numbers. It was about the widening of perspective. 3i Atlas arrived not only as a scientific subject but as a story, one that blended fact and imagination, certainty and mystery. In its light, however faint, people saw what they most needed: proof of connection, proof of surprise, proof that the night sky still had secrets to share. And so, as we close this chapter on how we first met our visitor, we turn to a deeper question. What does it really mean to call something interstellar? How rare is such a wanderer, and how does its presence reshape the way we see our place in the cosmos? When astronomers describe an object as interstellar, they mean something very specific. It is not simply distant or unusual. It is not just a comet flung far from the sun, or an asteroid from a shadowed corner of the Kuiper belt. To be interstellar is to be a wanderer from another star entirely. Every familiar comet in our sky is, in a sense, a child of our solar system. Born billions of years ago in the frozen outer reaches, they trace elongated ellipses that eventually bring them close to the sun, then fling them outward again. No matter how far they travel, they remain tethered, bound by the sun's gravity, destined always to return. An interstellar object is different. Its orbit is hyperbolic, a curve not of return, but of farewell. It does not loop back. It comes rushing in from deep space, swings past the sun once, and then escapes forever. Like a stone skipping across a pond, its path cuts through our neighbourhood and continues outward, pulled by no master but the galaxy itself. This distinction may sound mathematical, a quirk of geometry, but it carries profound meaning. To call something interstellar is to acknowledge that it was not formed here. It carries within it the fingerprints of another system, the chemistry of alien suns, the scars of collisions around planets we will never see, the icy memory of a nursery light years away. For centuries, scientists suspected such objects must exist. The galaxy is full of collisions. Stars form, planets grow, debris is cast adrift. Surely, they reasoned, fragments must escape into the void, drifting between stars, but until recently we had no proof. The night sky was vast, our instruments limited, and the interstellar wanderers passed unseen. Then came Oumuamua, slender and tumbling, its path undeniable, then Borisov, trailing a comet's veil, and now 3i Atlas, the third to be recognized. 3 in just a few years after centuries of silence. Suddenly, what was once speculation became reality. Interstellar objects are not rare curiosities. They are a part of our cosmic environment, as natural as meteors streaking through the night. Yet they are not common either. Even now, the number we can observe is vanishingly small. They slip past us quickly, faint and hard to track, each a brief opportunity. Most will never be noticed at all, lost in the sweep of stars. That is what makes each encounter feel like a gift, fleeting, improbable, and rich with possibility. To call 3I Atlas interstellar is to place it in this new category of wonders, messengers from beyond, carrying stories we are only just learning how to read. And with each visitor, we are reminded that the boundaries of the solar system are not walls, but thresholds. To understand how unusual these wanderers are, it helps to imagine the scale of the galaxy. Our Sun is just one star among hundreds of billions in the Milky Way. Around each of those stars, planets form, asteroids collide, and comets drift in icy reservoirs. From time to time, gravitational encounters fling fragments, loose pieces of rock and ice ejected from their birthplaces, set free into interstellar space. Once released, these fragments no longer belong to any system. They drift through the galactic sea, pulled only gently by the collective gravity of billions of stars. For them, the spaces between suns are not empty but highways, stretching endlessly in all directions. Some may wander for millions of years without ever encountering another system. Others, by chance, pass close to a star and are briefly illuminated, noticed, measured, before they move on again. For earthbound observers, the odds of witnessing such an event were once thought impossibly small. The sky is vast, the objects are tiny, faint, and fast. To catch one in the act of passing seemed as unlikely as spotting a single leaf blown across a desert at night. And yet, once telescopes reached the right sensitivity and surveys became constant, the improbable became reality. This shift in perspective is more than scientific trivia. It is a reminder that the solar system is not an isolated bubble. For most of history, humanity pictured our cosmic home as self-contained, its borders defined by the Oort cloud, its motion set by the Sunday, but interstellar visitors prove otherwise. They show that we live in a neighborhood with open doors, a crossroads through which countless travelers may pass. The rarity of our observations does not mean the objects themselves are rare. On the contrary, astronomers now suspect there may be countless interstellar wanderers moving unseen all around us at any moment. Most are simply too faint, too small, or too distant to detect. What we see a handful in just a few years may be only the brightest tips of a vast hidden population. To say that 3I Atlas is interstellar, then, is to recognize its role as both exception and representative. Exception, because we can see it at all. Representative, because it stands for countless others, reminders that the galaxy's stories are written not only in stars but in the fragments that slip free and find their way to us. The word interstellar carries with it a sense of distance almost beyond comprehension. Light itself, the fastest traveller we know, needs years to move between stars. For an object like 3I Atlas to arrive here, it must have wandered unimaginable gulfs of time and space, crossing regions where no sunlight shines, where silence is measured in millions of years. That journey alone makes it precious. Unlike comets born of our own system, which carry the familiar signatures of the sun's nursery, an interstellar fragment brings with it the fingerprints of another star's birth. Its ices may contain ratios of gases unknown in our catalogues. Its minerals may tell of collisions or conditions that shaped worlds we will never see. In a very real sense, each such object is a tiny sample return mission from another corner of the galaxy, delivered free of charge, if only we are able to catch it in time. And yet, this is what makes them bittersweet. They come fast, they come faint, and they do not linger. Even the best telescopes cannot hold them long. Even the boldest missions cannot chase them once they are gone. Each visitor is a brief conversation at the edge of the night, a chance encounter with a traveller who will not stay for tea. It is this tension between their rarity as observations and their abundance in reality that defines them. For scientists, they are puzzles, windows into distant processes. For dreamers, they are proof that the galaxy is alive with motion, that we are not alone even in emptiness. And for all of us, They are reminders that the boundaries we imagine, the edges of the solar system, the borders of the familiar, are not solid walls. They are thresholds, crossed again and again by strangers we may never meet. 3I Atlas belongs to this category. Rare to our eyes, yet inevitable in the grand scheme. Its presence is at once improbable and certain, fleeting and eternal. To call it interstellar is to accept that the universe is porous, that our skies are open, and that the stories written across the stars sometimes arrive at our doorstep in the form of a single fragile light. And so, having placed 3I Atlas in its true category, a wanderer from beyond, we now turn to its predecessors. For this is not the first time the universe has sent us such a messenger. Before this green-glowing traveller, there was Oumuamua, there was Borisov. Each left its mark, and together they form the lineage that 3I Atlas continues. Before 3I Atlas was ever noticed, two other wanderers had already brushed past our cosmic doorstep, each carrying its own story, each reshaping the way we think about what it means to live in an open galaxy. The first was Oumuamua, discovered in October 2017 by astronomers in Hawaii. Its name, chosen from the Hawaiian language, means a messenger from afar arriving first. The title was fitting, for Oumuamua was not only the first interstellar object humanity had ever identified, but also one of the strangest. Unlike the comets and asteroids we knew, its shape appeared elongated, like a shard or a spindle, tumbling end over end as it flew. Its brightness flickered dramatically as it rotated, hinting at proportions never before seen. Even more puzzling was its lack of a visible tail. Comets that dive toward the sun normally trail clouds of gas and dust, streaming out in sunlight. Oumuamua showed none of this, and yet, when scientists traced its trajectory, they found it accelerating slightly, as though something invisible were pushing it. Radiation pressure from sunlight, jets of gas too faint to see, or something else altogether? Speculation bloomed. Some researchers half-seriously proposed it could be an alien probe, a relic of technology adrift in space. Others argued it was simply a comet with unusual chemistry, shedding material in ways we had not yet understood. But the truth was elusive. Within weeks, Oumuamua had faded beyond the reach of our telescopes, leaving behind more questions than answers. It was a riddle written across the sky, vanishing before we could solve it. Then, in August 2019, another visitor arrived, this time leaving no doubt about its nature. It was called 2I divided by Borisov, after the amateur astronomer Gennady Borisov who first spotted it. Unlike Oumuamua, Borisov looked and behaved exactly like a comet. A glowing coma, a long tail, jets of gas streaming as it neared the Sunday. But it too was on a hyperbolic path, a one-time visitor from beyond. Borisov gave astronomers the luxury that Oumuamua had denied: time. It was bright enough and behaved predictably enough that telescopes around the world could study it in detail. Spectra revealed its chemistry surprisingly rich in carbon monoxide, even compared to comets in our own system. It was, in essence, a sample from another star's backyard, carrying with it the icy fingerprints of a different birthplace. Together, these two visitors reshaped the narrative. Oumuamua showed us the strange and ungraspable, the messenger slipping away too quickly to know. Borisov showed us the familiar, the comet that proved our theories right. And then, not long after, came 3I Atlas, standing somewhere between the two, strange in its chemistry, fragile in its behavior, yet visible long enough to remind us that interstellar encounters were becoming part of our story. Looking back, it is striking how different those first two interstellar guests were, and how much they revealed by contrast. Oumuamua was elusive, dim, fast and ambiguous. It forced astronomers to confront their limits. With only a brief window of observation, every measurement became a puzzle piece, and no matter how they fit them together, the picture remained incomplete. It was like glimpsing a shadow slipping past a doorway, leaving only the question of what had just passed. Borisov, by contrast, was almost comfortingly ordinary. Its behavior matched the language of comets we already knew. It had a nucleus wrapped in a glowing coma, it sprouted a tail, and its chemistry could be measured with familiar tools. It felt less like an intruder and more like a cousin from abroad, foreign, yes, but recognizable. What these two taught us, side by side, was that the galaxy's debris is as varied as the stars themselves. Some fragments may be strange beyond recognition, shaped by processes we barely understand. Others may look familiar, reminding us that planetary systems across the Milky Way share the same raw materials, the same chemistry of ice and rock. Between them, they also shifted our sense of scale. For centuries, comets were seen as omens or curiosities, bound to our sun's orbit like everything else we knew. The discovery of Oumuamua and Borisov broke that illusion. They showed us that fragments of alien worlds really do pass by, close enough to measure, close enough to stir our imagination, and perhaps most importantly, they prepared us for what came next. By the time 3i Atlas appeared, the world was ready to see it not as an isolated oddity, but as part of a growing pattern. First came the stranger we could not grasp, then came the comet that felt familiar, and now, with 3i Atlas, we were beginning to see the outlines of a new category altogether: interstellar objects as a recurring feature of our cosmic neighborhood. What lingers most about those first encounters is not only the science, but the feeling. When Oumuamua slipped past in 2017, its presence unsettled both scientists and the public. The data pointed to something real, yet its details resisted every explanation. Too elongated to be a typical asteroid, too fast to be bound, no tail yet a mysterious acceleration. It was as if the universe had whispered a riddle, and then, before we could even write it down, snatched the page away. For many people, Oumuamua became a symbol of possibility. Harvard astronomer Avi Loeb suggested, controversially, that it might be artificial, the fragment of a solar sail or probe. His argument made headlines worldwide, sparking debates that still echo today. Even those who disagreed admitted the object's strangeness made such speculation tempting. After all, what better candidate for alien technology than the first interstellar object we ever saw? Borisov, arriving 2 years later, carried a different mood. If Oumuamua had stirred unease, Borisov felt almost like reassurance. Its form, its behavior, its tail stretching across the sky, all were familiar. The fact that it came from another star was astonishing, but in every other respect it acted like a comet we might have seen in childhood sky charts. It told us, the universe is strange, but not incomprehensible. Other systems make comets too. Placed together, the two offered balance. Oumuamua taught humility: the universe can present us with mysteries we cannot yet solve. Borisov taught continuity: we are not unique, and the processes that shaped our solar system play out across the galaxy. One was the riddle, the other the answer, and together they formed the opening of a dialogue we had never before imagined we would have, a dialogue with the galaxy itself. So when 3i Atlas appeared, it did not arrive in a vacuum of meaning. It arrived in the shadow of these two predecessors, carrying expectations already heavy with story. Would it be another enigma, impossible to classify? Would it be another comfort, familiar and predictable? Or would it straddle both worlds, strange enough to tantalize, but present long enough to study in detail? As we would learn, it was indeed the third path. 3i Atlas borrowed something from each of its forerunners. Like Oumuamua, it behaved unpredictably, its brightness flaring and dimming in ways that defied forecasts. Like Borisov, it revealed a chemistry rich in peculiar ratios, different enough to mark it as foreign, but still bearing the fingerprints of cometary kinship. In this way, it embodied both mystery and familiarity, and perhaps that is why it captured so much attention. Together, the trio mark the beginning of a new era. For all of human history before them, we never knew for certain that fragments from other stars passed through our skies. In less than a decade, we saw three. That shift is more than coincidence. It is a redefinition of perspective. It tells us that the solar system is not a walled garden, but a crossroad. That our night skies are not only filled with our own debris, but occasionally touched by the stories of other suns. And as we trace these predecessors, we see the larger picture forming. Oumuamua, Borisov, and 3I Atlas are not isolated curiosities. They are the opening chapters of a book we have only just learned how to read. The universe has been sending such visitors for billions of years. Only now, with sharpened instruments and patient eyes, are we beginning to notice, and what we notice changes us. And so, having placed 3I Atlas in the lineage of its predecessors, we turn next to its own journey, the path it cut through the solar system, the trajectory that marked it as an interstellar wanderer, a hyperbolic arc of arrival and departure with no promise of return. Every object in the solar system tells its story through motion. Planets circle the sun in nearly perfect ellipses year after year, their orbits predictable for millennia. Comets dive inward on elongated loops, brightening as they pass close, then fading as they retreat to the frozen dark, only to return centuries later. Even asteroids, scattered and chaotic as they may seem, are still bound to the sun's gravity, looping endlessly in its embrace. But the orbit of 3I Atlas told a different story from the beginning. When astronomers mapped its path, the curve was unmistakable, not an ellipse, but a hyperbola. In mathematics, that simple distinction means everything. An ellipse closes in on itself, a hyperbola does not. It cuts through the solar system on a one-way trajectory, never to circle back, never to become part of our familiar family of comets. The numbers were clear. Its eccentricity, the measure of how stretched an orbit is, was greater than 1, proof of an interstellar origin. The sun could bend its path, but not capture it. Like a traveller hurrying through a station, 3I Atlas would pause only briefly in our neighbourhood before continuing outward into the endless dark. To think of an object moving this way is to glimpse the immensity of galactic traffic. Most of the bodies we know are permanent residents, anchored to the sun's domain. An interstellar object, by contrast, is a drifter. It does not belong here, nor will it stay. Its trajectory is not a loop, but a line. Its history measured not in revolutions, but in distances crossed. For earthbound observers, this gave the discovery a bittersweet quality. We were witnessing something extraordinary, a fragment from another system, perhaps another star's comet belt or planetary collision. But we were also witnessing it only once. There would be no second chance. Once it slipped past perihelion, the point closest to the sun, it would recede forever, shrinking into darkness, a memory more than a presence. This sense of impermanence is part of what made 3I Atlas feel so haunting. It arrived suddenly, it shone with strangeness, and already it was leaving. Even as astronomers tracked it night by night, they knew the story had an ending written from the start. There is no orbit that returns, no cycle to repeat, only the passing, and then the silence. When plotted across the star charts, the path of 3I Atlas looked less like the neat loops of a comet and more like the arc of an arrow. It entered our solar system at high speed, descending from the far north of the celestial sphere. The sun's gravity tugged at it, bending its route, but only slightly, just enough to curve its course before releasing it back into the galactic dark. At its closest, it swept between the orbits of Mars and Earth, never posing a danger of collision but close enough to spark the imagination. For weeks, telescopes followed its progress, measuring the angle of approach, watching the glow intensify as solar heat stripped away frozen gases. Each data point confirmed the same truth. This was no returning traveller. Its velocity was too great, its eccentricity too high. Once it crossed perihelion, it would be gone. To the human mind, raised on cycles and returns, such a trajectory feels alien. The moon circles endlessly, seasons repeat. Even comets like Halley's are predictable, their paths looping back every few generations. But 3I Atlas, belonged to no cycle we could claim. Its story with us was a single sentence, not a recurring chapter. It had been wandering for perhaps millions, even billions, of years before brushing past our sun, and it would wander for countless more afterward. Some astronomers speculated about its origin. Perhaps it had been ejected from a star-forming region long ago, tossed outward by the gravitational dance of giant planets. Perhaps it was the shard of a collision, the debris of worlds we will never know. Its hyperbolic path was a fossil record of that exile, a record written not in stone but in motion. What was striking, too, was how little the sun could do to alter its fate. Stars are anchors, holding their planets and comets in steady orbits. But for an object like 3I Atlas, passing through at interstellar speed, even the sun's pull was not enough. Our star bent it, warmed it, lit it briefly, but could not keep it. To watch its path was to be reminded that even the greatest lights in our sky are not rulers of all they touch. Some things pass through, untethered, answering only to the gravity of the galaxy itself. And so its orbit became not only a scientific curiosity but a metaphor. Here was a traveller defined by impermanence, a reminder that not every story in the universe is cyclical. Some are linear, fleeting and unrepeatable. We are accustomed to returns, of dawn, of seasons, of orbits. But 3I Atlas came to teach us that not everything circles back. Some things arrive, leave their impression, and are gone forever. In the weeks after its discovery, astronomers produced elegant simulations of 3I Atlas's orbit, glowing arcs traced across the solar system, each frame showing its rapid approach and inevitable departure. These diagrams were beautiful in their precision, but also poignant in what they implied. There was no path back. The calculations suggested it had already travelled light years, perhaps tens or hundreds of them, before intersecting our sky. Where it began, we cannot say. Its motion might trace back to a distant stellar nursery, or to the debris field of some ancient collision in a system that no longer exists. By the time it reached us, the stars it once circled may have shifted, aged, or even died. Its birthplace is lost to us, buried in the churn of galactic time. What we do know is where it was headed. Once past perihelion, its trajectory aimed outward again, toward the edge of our solar system and beyond. Astronomers mapped its future course, and saw it was destined to become invisible, fading into darkness, its speed carrying it ever farther from the warmth of our Sunday. In a few months, it would be too dim for telescopes. In a few years, it would be gone from memory, except for the faint records of its visit. For observers who followed it night after night, this inevitability gave the experience a tender edge. To watch 3I Atlas was to know you were witnessing something profoundly temporary. Like a comet glimpsed once through a childhood telescope, it would never return to the same patch of sky. Each moment of observation was unique, unrepeatable, and slipping away even as it was recorded. Its orbit, then, was not just a set of numbers. It was a narrative written in motion, a story of arrival, passage, and farewell. And as it receded, many felt the same impulse to wonder what other wanderers might one day pass through, and whether we would be ready to greet them. 3I Atlas reminded us that we live not in a closed system, but on a cosmic thoroughfare. Traffic does not stop at the borders of our sun's domain. Visitors arrive, stay briefly, and vanish into the galactic night. Their orbits may never return, but their presence leaves us changed, more aware of the vast currents flowing all around us. And in the next section, we turn to the subtler mysteries, not only its path across the sky, but the way its light itself betrayed secrets. For 3I Atlas did not just move strangely. It shone strangely too, with colours and flares that left astronomers puzzled and dreamers captivated. Light is the language of the cosmos. Everything we know about distant stars, galaxies and comets is written in the faint photons that reach our telescopes. With 3I Atlas, that light told a story that was both familiar and strange. a shimmer that at times seemed to belong to comets we already knew, and at other times hinted at something less ordinary. Early observations revealed a greenish glow around its nucleus. This is not unheard of. Many comets shine faintly green as diatomic carbon C2 molecules fluoresce under sunlight. Yet in 3I Atlas, the effect seems stronger, more pronounced, as though its chemistry held an extra charge. The green halo expanded outward, a ghostly mist that gave the object an otherworldly presence, even in photographs. Spectroscopy deepened the mystery. Instruments designed to split light into its component colors revealed that 3I Atlas carried unusually high levels of carbon dioxide. Compared to the comets catalogued in our solar system, its ratios were out of balance, leaning heavily toward volatiles that suggested it had formed in colder, darker regions than most of our local icy wanderers. Some readings even hinted at nickel in unexpected abundance, brighter in its spectral lines than the more common iron. Astronomers puzzled over these results. Why would a comet from another star system carry such chemistry? Was its birthplace a nursery cloud richer in certain elements? Or had it endured collisions and transformations that left it chemically scarred? The data gave no definitive answer, only more questions. What struck observers most, however, was the way its brightness refused to follow the usual script. Most comets brighten predictably as they approach the sun, their ices boiling off in steady increase. 3I Atlas flared in bursts. On some nights it surged with sudden brilliance, glowing more intensely than models predicted. Then, as quickly, it dimmed, shrinking back into obscurity. This behavior invited speculation. Perhaps its crust was unusually fragile, breaking open in vents that released gas in unpredictable spurts. Perhaps it was fragmenting, pieces breaking away to catch sunlight for a brief flash before vanishing. Or perhaps, whispered the more imaginative, it was something else altogether, a signal, a disguise, a rhythm we did not yet understand. Whatever the explanation, the light of 3I Atlas ensured it would not be forgotten. Photographs captured its emerald hue, news outlets highlighted its strange chemistry, and in quiet observatories, astronomers stared at graphs of spectral lines, knowing they were reading the story of a world that had once circled another star, now flickering in its only appearance here. As the weeks of observation continued, 3I Atlas behaved less like a passive fragment of ice and rock, and more like a performer with an unpredictable script. Each flare of brightness set off a scramble in the astronomical community. Teams compared notes, amateurs cross-checked images, and professional surveys adjusted schedules to catch the comet at its next outburst. The irregular light curve was especially frustrating. A comet's brightness is usually a reliable guide to its activity, tied to the rate at which frozen gases sublimate into vapor as sunlight warms the nucleus. With 3I Atlas, the pattern was broken. Sometimes its glow swelled days ahead of prediction, other times it dimmed without warning, leaving telescopes staring into darkness where a comet should have been. Even stranger was the geometry of its tail. Most comets grow a single long, thin plume streaming directly away from the sun, pushed by the solar wind. 3I Atlas developed complex structures, overlapping fans, asymmetric arcs, even hints of twisting filaments, like smoke caught in shifting winds. These shapes flickered and changed within days, suggesting bursts of gas jetting from different parts of its surface, each one shifting the overall appearance. The science was challenging, but the imagery was mesmerizing. Photographs circulated online showed a comet that looked alive, draped in emerald mist, its tail bending and curling like a living creature. For ordinary viewers, it became a kind of celestial spectacle, not a static dot, but a restless ghost, shape-shifting across the sky. Researchers debated the cause. One hypothesis suggested the comet's structure was unusually porous, riddled with cavities that collapsed under sunlight, venting gases in chaotic bursts. Another pointed to the possibility of fragmentation, with small pieces breaking off and briefly flaring as they vaporized. A third, More daring wondered if the comet's chemistry, so unlike that of familiar solar system objects, meant it obeyed rules we had not yet encountered. To dreamers, of course, the explanation didn't matter. What mattered was the spectacle, a green light flaring in the night, unpredictable and untamed. Some likened it to a cosmic heartbeat, pulsing as it moved closer to the Sunday. Others saw it as a messenger signaling in a language we had yet to decode. Whatever the truth, 3i Atlas refused to behave like anything ordinary. It would not let itself be catalogued neatly, checked off as just another comet. Its light carried both science and story data for the instruments, and mystery for the imagination. And for those who followed its nightly dance, it left a sense of intimacy, as though the comet itself were aware of being watched, and chose to perform in bursts of brilliance before fading again into silence. By early spring, 3i Atlas had become one of the most watched objects in the sky. Telescopes tracked its restless glow, satellites measured its emissions, and astronomers debated every fluctuation of light. Yet for all the precision of their instruments, the comet kept its secrets. Each new set of readings only seemed to complicate the story further. The chemistry alone defied expectations. Carbon dioxide dominated its spectrum, far beyond the ratios seen in most solar system comets. Nickel lines shone brightly, hinting at metallic grains being released from its surface in quantities unusual for such a fragile body. Together, these signatures painted the portrait of an object born under conditions alien to us, perhaps in a disk, colder, denser, or more turbulent than the cloud that once birthed our Sunday. Its brightness, too, spoke of instability. The sudden surges and collapses suggested a nucleus on the verge of breaking apart, as if the comet carried within it the memory of stresses endured during its long interstellar voyage. Each flare could have been a scar reopening, each dimming the exhaustion of a body nearing its limit. To scientists, these irregularities were valuable puzzles. To the wider world, they were invitations to imagine. People wrote poems comparing its green glow to lanterns drifting across the sky. Artists painted its tails as luminous veils, twisting like ribbons in cosmic wind. Some even wondered aloud if its strange flares were not accidents of chemistry at all, but deliberate, the blinking of a signal, the shimmer of something crafted rather than natural. The truth, of course, leaned toward the natural. Yet the beauty of astronomy lies in its ability to hold both certainty and wonder at once. 3i Atlas could be explained in terms of volatile gases, weak structures, and unusual chemistry, and at the same time it could be experienced as a ghostly apparition, an emerald wanderer lighting our sky for one brief season. For those who followed its journey, the lesson was clear. Not all comets are alike. Some shine steadily, predictable in their arcs of light. Others, like 3i Atlas, defy the script, performing in bursts and shadows, leaving us unsure whether to classify them as anomalies or as heralds of a wider diversity we are only beginning to glimpse. Its strange light was both a scientific clue and a poetic gift. It told us something about its origins, while also reminding us how much remains unknown, and as it brightened and dimmed for the last time, it prepared us for the next stage of its story, the moment when its fragile structure would fail and the visitor would begin to come apart. And so, in the next section, we witness the unravelling, the slow fragmentation of 3i Atlas, a reminder that even the most mysterious visitors are not immortal. Like sparks fading in the night, its death became another chapter in its fleeting tale. From the moment it was first noticed, astronomers suspected that 3i Atlas might not endure. Its restless brightness, its sudden flares and collapses, all hinted at a fragile body under strain. Comets, after all, are not solid monuments. They are loose conglomerates of ice and dust, cosmic snowballs held together only by their own frail gravity. When sunlight warms them too quickly, when stresses build inside their porous shells, they fracture, they unravel. By late March of its apparition, the predictions grew darker. Reports from telescopes showed that 3I Atlas was no longer a single coherent point of light. Instead, its nucleus appeared elongated, blurred, as if it was stretching apart. On clear nights, sensitive instruments revealed fragments peeling away, each one glowing faintly before fading into the comet's green mist. The death of a comet is both dramatic and quiet. There are no explosions heard across space, no shockwaves racing outward, only the subtle unbinding of a body too fragile to hold itself together. Pieces drift, scatter, and dissolve into the vacuum. What was once a single traveller becomes a stream of debris, soon indistinguishable from the background dust of the cosmos. For those who had followed its strange performance, the breakup of 3I Atlas felt like the closing of a curtain. The green glow dimmed, its tail thinned, and its once enigmatic light curve collapsed into silence. The visitor that had sparked speculation around the world was unravelling before our eyes, returning not to another orbit, but to nothingness. And yet, in that quiet disintegration lay a kind of poetry. To watch a comet die is to be reminded of impermanence, of how even the most mysterious guests cannot remain. Like a spark carried on the wind, 3I Atlas burned briefly and was gone, its fragments dispersed into the solar wind, destined never to be seen again. Some astronomers called it disappointing, a scientific opportunity cut short. Others saw it as a gift, a rare chance to study a comet's structure in the moment of collapse. But for many, the spectacle carried a more personal meaning, a reminder that beauty often lies in transience, that some lights are precious precisely because they fade. As more observatories confirmed the breakup, the story of 3I Atlas shifted from mystery to elegy. Just weeks earlier, its strange flares had inspired theories of hidden forces and exotic chemistry. Now the narrative was simpler, though no less profound. The comet was dying. Its fragile body, perhaps weakened by eons of exposure in interstellar space, could not withstand the sudden furnace of the Sunday. Images captured by powerful telescopes showed a nucleus no longer intact. Instead of a solid point, there was a scatter of smaller lights, each one a fragment of the whole. Like embers drifting from a fading fire, they glowed briefly before dispersing into the larger coma of gas and dust. What had once seemed alive with pulses and rhythms was now revealed to be fragile, brittle, and short-lived. Astronomers measured the speed of the fragments, their faint trails across the stars. Some would dissolve quickly, shedding vapour until nothing remained. Others might persist as tiny, inert rocks, too small to notice, swept silently along the hyperbolic path of their parent. Either way, the identity of 3I Atlas was dissolving, transformed from a singular visitor into a nameless cloud. For the public, this ending carried a strange intimacy. News outlets spoke of the comet's death. Headlines framed it as a tragedy. People who had followed its story online shared a sense of loss, as though a character in a shared tale had vanished. Of course, comets die all the time, fragmented, evaporated, ground down by the gravity of planets. But the knowledge that this one was interstellar, that it had wandered so far only to break apart here, lent its demise a special poignancy. Some saw in its disintegration an echo of human experience. We, too, are temporary, fragile against the forces of time. We flare brightly for a moment, then fade, our atoms scattered back into the cosmos. The comet's death became a mirror for our own impermanence, a cosmic reminder that nothing endures forever, yet everything leaves traces. And in that sense, 3I Atlas was not lost entirely. Its fragments joined the solar wind, its dust stretched into space, its story embedded in the memory of those who observed it. Even as its body dissolved, its legacy remained a lesson in both science and humility. By the time April passed, 3I Atlas was no longer the comet people had once imagined. Its nucleus had unravelled into dozens of pieces, its light dispersed into a faint haze. Telescopes that once caught its emerald glow now recorded only smudges of dust. The interstellar visitor, so briefly a source of wonder and speculation, was gone, but absence can speak as loudly as presence. In classrooms, astronomers explained how fragile comets really are more like piles of powder than solid stone. In observatories, researchers combed through data, piecing together how its chemistry and structure might have doomed it to collapse. And in quieter corners, ordinary skywatchers reflected on what it meant to watch a traveller die in transit. For scientists, the breakup was a valuable gift. Fragmentation exposed inner layers that would otherwise have remained hidden. By studying the debris, they learned more about its volatile ices, its dusty composition, its fragile bonds. Even in death, the comet was teaching. For dreamers, though, the lessons were less technical and more human. 3i Atlas reminded us that transience is part of beauty, that a light which flares briefly can be more moving than one that endures forever. Its disintegration was a cosmic performance of impermanence, echoing truths we often resist. Everything changes, everything passes, and sometimes the most fleeting encounters leave the deepest marks. As its dust thinned into the night, many felt an odd gratitude. To have lived in the narrow window when this interstellar fragment visited, to have seen it shimmer and dissolve, was to share in a story written across time and space. Millions of years of wandering had ended here, in our skies, before our eyes. And then it was gone. A silence replaced its glow, leaving behind only data, photographs, and memories. 3i Atlas would never return. Yet in its passing, it left us altered, reminded of how small, how brief, and how precious our moments of wonder truly are. And so, from the fading light of a comet's death, we turn to the realm of explanation. For every mystery inspires a search for cause. What could science say about 3i Atlas, its chemistry, its origins, its collapse? In the next section, we explore the hypotheses that try to bring order to the enigma it left behind. When an object as strange as 3i Atlas crosses our skies, science does what it always does. It asks why. Why was its chemistry so unusual? Why did its brightness flare unpredictably? Why did it fragment so quickly, as if its structure had already been weakened long before the sun's heat reached it? The first set of hypotheses pointed to its origin. Comets are time capsules, formed in the frozen outer regions of planetary systems. Their chemistry reflects the nursery in which they were born. The unusually high levels of carbon dioxide in 3i Atlas suggested that it had formed in a particularly cold environment, colder perhaps than anything in our own solar system. In such deep freeze conditions, volatile gases that would not survive here could be locked safely into ice, preserved for billions of years until sunlight finally coaxed them out. This would explain the comet's intense green glow, the strong emission lines that puzzled astronomers. It may have been carrying compounds common in its birthplace, but exotic to us. In this view, the comet was not an anomaly but a messenger, revealing the diversity of planetary systems across the galaxy. Just as no two stars are identical, no two nurseries of comets need be the same. Another line of reasoning focused on its fragility. Why did it break apart so quickly? Some scientists argued that the comet's long interstellar journey had damaged it. Over millions of years drifting through the galactic medium, it may have endured collisions with micrometeoroids or been bombarded by cosmic rays, leaving its surface brittle and cracked. By the time it neared our sun, it was already too fragile to survive. The heat was not the cause of its death, merely the final push that exposed weaknesses built up over eons. Still others proposed that its breakup reflected internal stresses. Comets are patchworks of ice, dust and rock, bound loosely by gravity. As different layers warm unevenly, pressure builds inside. Vents open suddenly, jets burst outward, and sometimes the entire nucleus crumbles. With 3i Atlas, the sudden flares of light before its disintegration seem to support this view. Each burst may have been a crack giving way, a fracture spreading until the whole body gave out. These explanations were cautious, grounded in physics and chemistry. They painted the comet not as a mystery beyond comprehension, but as a reminder of natural diversity. 3I Atlas, in this light, was simply a comet shaped by different conditions, carrying different ices, doomed by a fragile structure. A wanderer, yes, but a natural one. And yet, even within science, the word simply felt insufficient. For every hypothesis answered one question, it raised another. If its chemistry was exotic, what kind of star system had birthed it? If its fragility was the cause of its demise, how many other fragments like it drift invisibly through the galaxy? In science, answers are never final. They are stepping stones, carrying us from one question to the next. Another hypothesis emerged from the way 3I Atlas behaved in its final weeks. The comet's unpredictable flares of brightness burst that seemed to ignite, then collapse suggested a nucleus riddled with weakness. Some researchers proposed that this fragility might not be random, but the scar of a violent beginning. Perhaps 3I Atlas was not a pristine object formed gently in some quiet nursery, but a fragment torn loose during a cataclysm. Planetary systems, especially in their youth, are turbulent places. Giant planets shift inwards and outwards, scattering smaller bodies like pebbles kicked across a floor. Collisions are common, some so massive they can strip atmospheres or shatter worlds. If 3I Atlas was born in such a system, it might have been broken from a larger body, blasted free by a collision with another comet or asteroid. The stress of that ancient impact could have left fractures running deep within it, fractures that finally tore open as it neared our Sunday. Others looked further back still, imagining the interstellar environment itself as the sculptor. For millions of years, perhaps billions, the comet wandered between stars. In that cold and silent expanse, it endured the constant rain of cosmic radiation. Protons, electrons, and heavy particles from distant supernovae would have pelted its surface, altering its chemistry, eroding its bonds. Over unimaginable spans of time, even the hardest ice becomes brittle. The faint shimmer of green and the eventual breakup might have been not signs of mystery, but scars of age, a body weathered by the galaxy itself. There was also the question of its speed. Interstellar objects move faster than anything born of the sun because they are not bound. Some scientists suggested that this velocity placed 3I Atlas under stresses few comets experience. The faster it moved, the sharper the thermal shock as it approached perihelion. Its surface may have warmed unevenly, triggering violent outgassing that split it apart. In this sense, its death was not unusual at all, only accelerated by the conditions of its journey. Yet none of these explanations erased the strangeness entirely. The chemistry remained peculiar, the flares remained inconsistent. The timing of its fragmentation, just as public fascination reached its peak, seemed almost theatrical. The scientific models offered pieces of understanding, but the comet itself refused to be reduced to a single neat story. Perhaps that too is the lesson. Science does not always deliver closure. Sometimes a discovery leaves us with probabilities rather than certainties, with competing theories rather than consensus. 3I Atlas fit this mold. It was natural, yes, but in ways that reminded us how diverse natural can be. It obeyed physics, yet in forms unfamiliar enough to stretch our imagination. It left behind data, but also wonder. And in that balance between knowledge and mystery, it joined the long tradition of cosmic visitors, who remind us that science is not the opposite of awe, but its companion. The more we learn, the deeper the questions become, and the more brightly the mystery glows. In the end, most astronomers agreed that 3I Atlas was best understood not as a singular anomaly, but as a representative of possibilities. Its chemistry, its fragility, its strange light, each pointed toward a natural explanation, though none told the whole story on their own. One camp emphasized its origin in a colder region than our solar system ever offered. If it was born on the outer edge of another star's protoplanetary disk, its ices might contain volatile compounds that rarely survive here. The high carbon dioxide, the vivid green glow, the unusual balance of metals, all could be signatures of a nursery more extreme than our own. In this interpretation, 3I Atlas was a sample of diversity, a clue that planetary systems form comets under many different conditions across the galaxy. Another camp saw it as a body already weakened by time, after drifting for millions or billions of years, perhaps even being tugged past multiple stars. Its surface would have been scarred, its interior fractured. By the time it arrived in our neighborhood, it was living on borrowed strength. Its breakup was not a surprise, but the final unraveling of a body long past its prime. A third perspective combined both ideas. 3I Atlas was exotic in chemistry and aged in structure, a survivor of extremes. It carried with it the fingerprints of its birthplace and the scars of its long exile, both of which shaped its fleeting appearance in our skies. None of these explanations stripped the comet of wonder. If anything, they deepened it. To say that it was natural is not to say that it was ordinary. The natural world itself is extraordinary, and 3I Atlas was proof of how wide that spectrum can be. Its green shimmer was the glow of chemistry we had never seen up close. Its fragility was the weight of time, measured not in centuries but in cosmic ages. Its passage was a reminder that we are part of a galaxy filled with endless variations, each carrying secrets we have only just begun to glimpse. Science may prefer restraint, but even the cautious language of hypotheses could not diminish the feeling many had when looking at the comet. Here was a messenger, not of technology or intent, but of nature itself, a reminder that the universe writes stories stranger than any we might invent. And yet, for every sober explanation, there are always other voices. Where science sees chemistry and physics, imagination sometimes sees intent. As 3I Atlas flared, fragmented, and vanished, some wondered, could it be more than nature's wanderer? Could it be technology, a signal, even a vessel? In the next section, we turn to those more speculative ideas, the theories beyond science that the comet's strange light inspired. Whenever the universe delivers a mystery, imagination rushes to meet it. With 3I Atlas, the strange green glow, the sudden flares of brightness, and the dramatic fragmentation were more than enough to spark ideas far outside the boundaries of conventional science. The most common speculation echoed earlier debates about Oumuamua. Could this object be artificial? To some, the irregular surges of light looked suspiciously like signals. If comets normally brighten in predictable ways, why did this one pulse erratically? Was it shedding material at random or transmitting, flashing intentionally in ways we could not yet decode? Others pointed to the chemistry. The strong spectral lines of nickel and carbon dioxide were unusual enough to invite exotic explanations. What if the materials were not natural but remnants of construction? Could 3I Atlas be the shattered hull of some ancient craft, its green haze not outgassing but engineered exhaust, bleeding into space after eons of drift? The idea of an interstellar mothership also found its way into conversation. What if the fragmentation was not accidental but deliberate? To some, the breaking apart of the nucleus suggested the release of smaller probe shards designed to scatter into the solar system, invisible to us but carrying out some hidden purpose. The timing of its flares, coinciding with its closest approach to the sun, added to the intrigue. Was it simply a comet coming undone, or a vessel activating at the moment of maximum exposure? These ideas were speculative, yes, but they thrived in the cultural climate of curiosity and unease. The internet filled with discussions, some playful, others serious. Videos proposed scenarios where 3I Atlas was a scout, a messenger, or even a warning. In the silence of space, its flickering glow became a canvas on which every hope and fear could be painted. And it was not only ordinary people who entertained such thoughts. A handful of researchers, though cautious, admitted that they could not rule out artificial explanations entirely. The discipline of astronomy demands skepticism, But history reminds us that every once in a while, the universe delivers surprises. To close the door too firmly would be to risk missing the extraordinary. Still, even within speculation, there was a sense of humility. If Three-Eye Atlas were artificial, what would that mean? A relic of civilizations long gone? A probe launched from a star we cannot trace, carrying on a mission whose designers are now dust? The possibilities were as haunting as they were exhilarating. Beyond the theories of alien ships and hidden probes, other speculations lean toward the symbolic. What if Three-Eye Atlas was not a machine, but a message? Its appearance coincided with a time of global uncertainty, when people were already looking skyward for signs. Some saw its sudden brightness and eerie green hue as an omen, a celestial punctuation mark dropped into human history. In myth and folklore, comets have long been read as harbingers. The ancients spoke of them as fiery swords, portents of change, signals from the gods. Even now, with centuries of science between us and those beliefs, the instinct remains. A glowing stranger in the night sky still feels like a communication, a reminder that we are not in control. Three-Eye Atlas, with its dramatic flares and its untimely death, seemed to revive that archetype, a sign, not a coincidence. Some writers wondered if its fragmentation could itself be interpreted as a form of communication. A comet breaking apart is not unusual in astronomy, yet to those watching with symbolic eyes, the disintegration carried meaning. Was it a warning about fragility, about the impermanence of civilizations? Or was it an invitation, a demonstration that even across impossible distances, connections can be made in brief, dazzling encounters? Others spun still stranger theories. A few suggested that Three-Eye Atlas might be a kind of biological ark, not a spacecraft in the mechanical sense, but a carrier of organic material, a wandering capsule of panspermia. Perhaps its strange chemistry was not an accident but a signature of life, frozen and released in green flares as it approached the Sunday. To believers in cosmic seeding, the comet's brief existence in our skies was a whisper that life might be more universal than we dare to imagine. Even within more mystical circles, the comet became a touchstone. Astrologers mapped its trajectory against the planets, seeking meaning in its arc. Spiritual communities spoke of it as a catalyst for awakening, a traveller carrying energy from beyond our solar system. In these interpretations, the specifics of nickel or carbon dioxide didn't matter. What mattered was the feeling it evoked, the sense of being addressed by the universe itself. Skeptics dismissed these ideas as projections, reflections of human longing onto an indifferent fragment of ice. But even skeptics had to acknowledge that mystery has power. Whether natural or artificial, omen or accident, Three-Eye Atlas stirred imaginations in ways that pure data rarely does. Its unpredictability invited stories, and stories are the oldest way humans have made sense of the sky. By the time Three-Eye Atlas was fading into dust, the theories surrounding it had grown into a constellation of possibilities. On one end stood the sober voices of science, reminding us that nature can be strange without being supernatural. On the other end stood imagination, unfettered, turning the comet into ship, seed, or sign. And between them lay a fertile middle ground, a space where mystery itself had value, regardless of the explanation. Consider the notion of an interstellar probe. Even if Three-Eye Atlas was not one, the very fact that we could entertain the idea tells us something profound about where we are as a species. Just a century ago, the concept of alien technology passing through our solar system would have belonged purely to science fiction. Today, it lives in scientific journals, debated cautiously but earnestly. The boundary between speculation and hypothesis is not fixed. It shifts as our tools and our imagination evolve. Or take the idea of symbolism. Whether or not the comet was a message, people treated it as one. They saw in its sudden glow reflections of their own hopes and fears. They read its disintegration as an allegory for fragility, for endings, for the fleeting nature of life. In this way, 3I Atlas became less a physical object and more a mirror, a stage on which humanity projected its own questions. Sometimes, the value of a cosmic event is not in what it is, but in what it inspires us to ask. Even the wilder notions, motherships releasing swarms, signals hidden in spectral lines, fragments carrying alien microbes spoke to an enduring truth. We long for connection. We peer into the sky not only for knowledge, but for kinship. The possibility that something out there might acknowledge us, even wordlessly, carries a gravity as powerful as any star. In the end, whether the comet was natural or artificial mattered less to most observers than the fact that it reminded us of mystery. The universe had sent us a traveller we could not fully explain. And in its glow, whether green from chemistry or imagined as a beacon, we found room for both science and story. Perhaps that is the real lesson of the outside theories. They do not have to be true to be meaningful. They reveal the spectrum of human response: curiosity, fear, wonder, longing. 3I Atlas, fragmenting silently as it slipped away, became a stage for all of it. And so, stepping back from the comet itself, we widen our view. 3I Atlas was not alone. It belonged to a trend, a sudden wave of discoveries that told us interstellar objects were not accidents, but part of a larger cosmic pattern. In the next section, we'll explore how this realization changes our sense of the solar system and of our place within it. The story of 3I Atlas does not exist in isolation. Its arrival may have felt singular, but in truth it was part of a larger shift, a dawning awareness that interstellar visitors are not rare miracles, but recurring threads in the cosmic tapestry. For most of human history, we believed the solar system was a closed neighborhood. The planets, the moons, the comets, and the asteroids all belonged to the Sun's family, circling endlessly within its gravitational reach. Stars might shine beyond, but their worlds, their debris, their fragments, those were separate, unreachable, locked away by distance. That belief began to change in 2017 with the discovery of Oumuamua. It slipped past quietly, the first confirmed interstellar object ever seen. Its shape, its tumbling motion, its lack of a cometary tail all puzzled astronomers. But more importantly, its hyperbolic orbit was undeniable. It was not bound to the Sunday, it had come from elsewhere. 2 years later, in 2019, came Borisov, the second interstellar visitor, but this one, unmistakably, a comet, with a blazing tail and chemistry not unlike those of our own. Together, Oumuamua and Borisov suggested something radical, that interstellar objects pass through the solar system more often than we had ever realized. And then, in 2025, 3I Atlas, the third. Each new detection added weight to the idea that such travelers are not anomalies but part of the ordinary rhythm of galactic motion. We had missed them before because our instruments were weaker, our surveys narrower. Now, with powerful wide-field telescopes scanning the sky every night, the universe was revealing what had always been there, a steady trickle of guests from the stars. This realization reframes the way we see the solar system. It is not a sealed-off chamber, but a crossroads, a place where objects from distant origins occasionally pass through. The sun's gravity is strong but not absolute. Every so often, a fragment from another nursery, another world, another time, drifts across its light. For astronomers, this shift is thrilling. Interstellar objects are samples delivered for free, messengers carrying the chemistry of distant systems. They are fossils not only of our own solar system's past, but of countless others. With each detection, we expand our library of cosmic stories, learning that the diversity of worlds is greater than we had imagined. For the rest of us, the shift is more poetic but no less powerful. To know that visitors are passing through unseen in the past, visible now, is to feel less alone. The galaxy is not silent stone, it is dynamic, alive with motion. Stars share their fragments, scattering them into interstellar space, where they wander until chance carries them to new skies, and we, for a brief moment, get to watch them drift by. As astronomers reflected on 3I Atlas, they realized it was not just another comet, it was part of a sequence. One visitor might have been chance, 2 might have been coincidence, but 3, arriving within less than a decade, pointed to something deeper. Interstellar objects are constantly threading through our skies, unnoticed until recently. This realization carried profound implications. If 3 had been found so quickly, then the galaxy must be full of them. Thousands, perhaps millions, may drift silently through interstellar space, relics of planetary systems scattered by gravity, collisions, and time. Our solar system, moving through the galaxy, is like a ship crossing a busy ocean. From time to time, debris from other vessels washes against our hull. We had simply lacked the eyes to see it. The turning point has been technology. Modern sky surveys, with cameras that sweep vast fields of stars each night, have expanded our vision. Instruments like Pan-STARRS and the upcoming Vera-C, Rubin Observatory are designed not only to spot asteroids that might endanger Earth, but also to catch anything unusual objects moving too fast, or tracing arcs too wide to belong to the Sunday. 3I Atlas was a beneficiary of this vigilance. Without these tools, it would have slipped past unseen, a ghostly traveller leaving no trace. For planetary science, this is transformative. Until Oumuamua, we had no direct samples of material from beyond the solar system. Now, with each visitor, we glimpse alien chemistries. Borisov showed us a comet much like our own, but with subtle differences, proof that other systems form icy wanderers too. 3I Atlas, with its strange green glow and rapid disintegration, showed us another variation, stranger still. Each one expands the boundaries of what we expect from nature. It also reshapes our imagination of the cosmos. We used to think of stars as islands, each with their own planets, moons and comets, isolated by distance. But interstellar objects reveal that the galaxy is porous. Material does not stay confined. Worlds shed fragments. Systems share their debris. The space between stars is not empty, but alive with the drifting remnants of creation. For humanity, this is both humbling and inspiring. Humbling because it reminds us that the solar system is not unique or sealed off. Inspiring because it suggests that pieces of distant worlds are within reach. The idea that a shard from another star system could appear in our skies, glowing briefly before vanishing, is not only a scientific event, but a poetic one, proof that the galaxy is interconnected in ways we are only beginning to see. If the appearance of 3I Atlas was a singular event to the naked eye, to astronomy, it was a chapter in a growing narrative, one that stretches far into the future. The realization that interstellar visitors are common reframes not only our present, but also what comes next. The Rubin Observatory, when fully operational, is expected to discover dozens of such objects each decade. Some will be faint, barely detectable against the star fields. Others may blaze like comets, bright enough for amateurs with backyard telescopes to follow. Each will offer a chance to probe the chemistry and structure of worlds that orbit stars we may never see directly. 3I Atlas was a beginning, not an end. This raises an intriguing possibility. What if we could do more than watch? Already, mission concepts exist on paper to intercept the next interstellar visitor. A spacecraft launched quickly, armed with ion drives and compact instruments, might rendezvous with such a body, sampling its dust, even photographing its nucleus up close. The dream is no longer impossible. It is only a matter of timing and readiness. 3I Atlas passed too soon for us to react, but its successors may not. Seen in this wider context, the comet's fleeting presence becomes part of a grander story. It was not just a mystery to puzzle over, but a herald of a new field of astronomy. Just as the first exoplanet discoveries opened the floodgates to thousands more, The first 3 interstellar objects suggest a coming age when such encounters are routine. What feels rare today may soon feel abundant. And with abundance comes perspective. Each visitor will carry a different fingerprint, a record of its birthplace. Together, they will sketch a map of galactic diversity, icy wanderers from red dwarfs, dusty shards from young stars, metallic fragments from violent systems. In this way, interstellar objects may become the fossils by which we piece together the galaxy's history. For now, though, we remember 3I Atlas as a singular visitor because it was the one we saw, the one that flared in our skies. It belongs to the larger pattern, but it also belongs to us, to our time, our memory, our sky. And like any guest, it reminds us of 2 truths: that we live in a universe alive with motion, and that our own solar system is not an island, but a crossroad where paths sometimes meet. From this broader context, our minds inevitably drift to a quieter but haunting question. What if the comet had not simply passed by? What if, instead, its trajectory had intersected with ours? In the next section, we imagine that scenario not to frighten, but to explore what such a collision might mean. Speculation is a natural companion to discovery. The moment astronomers confirmed that 3I Atlas was on a hyperbolic path, destined to sweep past the sun and vanish forever, people began to ask a quieter question: what if its aim had been different? The reality is that 3I Atlas posed no danger. Its orbit carried it safely between the realms of Mars and Earth, never close enough to threaten. But imagining the alternative offers both a sobering lesson in cosmic scale and a chance to reflect on how fragile our world truly is. If an object like 3I Atlas were on a collision course with Earth, the first factor to consider would be size. Comets vary widely, some are just a few hundred meters across, others span tens of kilometers. Even a fragment, only a kilometer wide, could unleash devastation beyond anything in human memory. The energy of such an impact, released in a fraction of a second, would dwarf all the nuclear weapons ever built. Entire regions would be leveled. Climate itself could shift as dust and vapor filled the atmosphere, dimming sunlight for years. But the story would not always be apocalyptic. Much would depend on where the object struck. If it entered the atmosphere steeply, it might explode high above the ground, like the Chelyabinsk meteor of 2013, brighter and more destructive, but still localized. If it fell into an ocean, tsunamis would ripple outward, threatening coastlines but sparing inland regions. The range of outcomes stretches from catastrophic to survivable, depending on the details. The lesson, though, is constant. Our planet is small, our defense is limited, and the universe is indifferent. The same stars that nurture us also scatter fragments that could undo us. To imagine 3I Atlas on a collision course is to confront this vulnerability directly and to recognize why astronomers scan the skies so diligently, night after night. And yet, even in this imagined scenario, there is something strangely comforting. Catastrophe in the cosmos is rare. Objects of interstellar origin are rarer still. The odds of such a collision in our lifetimes are vanishingly small. What remains, then, is not fear but perspective, a reminder of how much we depend on chance, and how every ordinary day under a safe sky is its own quiet miracle. To picture an impact from 3I Atlas is to step into a scale of energy almost beyond imagination. Scientists often compare such events to the Tunguska explosion of 1908, when a small asteroid flattened thousands of square kilometers of Siberian forest. But that object was perhaps only 50 meters across. A comet nucleus hundreds of meters wide, or even larger, would release energy magnitudes greater. The math is straightforward yet staggering. The kinetic energy of an object depends on its mass and velocity. Interstellar visitors, like 3I Atlas, travel faster than typical comets, because they are not bound to the Sunday speeds of 40 to 60 kilometers per second are common. At those velocities, even a fragment the size of a mountain would strike with the force of millions of nuclear warheads. It would not simply scar the land. It could alter the climate, disrupt ecosystems, and leave a signature in the geological record. And yet, even here, nuance matters. Our planet has faced such impacts before. 66 million years ago, a body roughly 10 kilometers wide struck what is now the Yucatan Peninsula, triggering the extinction of the dinosaurs. But smaller impacts, though destructive, do not always tip the balance of life. Earth has a way of absorbing blows, healing scars, and continuing on. To imagine a strike from 3I Atlas is to remember that life has endured worse, and that our very existence may be partly due to such cosmic accidents. Astronomers often stress that imagining these scenarios is not meant to alarm, but to prepare. Planetary defense is a growing field, not because danger is imminent, but because prudence is wise. Just as sailors chart storms they may never encounter, scientists model collisions that may never come. 3I Atlas was not a threat, but it was a reminder that vigilance matters, and so the thought experiment becomes less about fear and more about humility. A comet is not malevolent. It carries no intention, no hostility. It is simply matter in motion, following the lines of gravity. If chance had aimed it differently, it might have been our disaster. Instead, it was our spectacle, a lesson written in light rather than fire. In that sense, imagining the what-if enriches the what-is. By seeing how fragile we might be, we appreciate the grace of safety. By picturing catastrophe, we notice the gift of ordinary nights, where comets pass by without harm and the stars above us remain undisturbed. If we allow ourselves to carry the thought further, to picture 3I Atlas not only approaching but striking Earth, the imagination divides into two parallel stories, one of destruction and one of meaning. The first is physical. Dust would rise into the atmosphere, dimming sunlight and cooling the planet. Crops might fail, forests might burn from shockwaves or tsunamis. The balance of ecosystems would shift, perhaps suddenly, perhaps over decades. These are the mechanics of catastrophe, the outcomes our models calculate when they translate mass and velocity into energy. But the second story is human. How would we respond to the knowledge that an interstellar traveller, older than our species, had ended its journey here? Would we see it only as disaster or as a strange kind of connection, a moment where two wandering bodies, planet and comet, finally crossed paths? History suggests that we would do both. We would grieve what was lost, we would rebuild what we could, and we would tell stories about it, weaving the comet into myth, transforming it from accident into symbol. Just as ancient peoples once read omens in the sky, so too would we interpret the fall of an interstellar visitor as more than physics. It would become part of our collective narrative, a reminder of fragility, but also of kinship with the wider cosmos. Thankfully, with 3I Atlas, we never faced that test. Its trajectory spared us, carrying it past the inner planets and onward into darkness. What it offered was not harm, but perspective, a chance to imagine the scale of cosmic forces and to measure our preparedness without ever facing the consequence. And so the what-if remains just that, a quiet speculation folded back into the larger story of its passage. The comet came close enough to stir our imaginations, far enough to keep us safe. In its passing, it left us not with scars, but with questions, and with a renewed sense of how thin the line can be between disaster and wonder. From here, our gaze turns outward again. If comets like 3I Atlas remind us of our vulnerability, they also remind us of our ingenuity. What tools have we built, and what plans are we making to protect ourselves from future wanderers whose paths may not be so kind? In the next section, we explore planetary defense, humanity's quiet preparations against the vast indifference of space. The thought experiment of 3I Atlas striking Earth may be only imagination, but it connects directly to a question that is very real. What if the next object does not miss? For the first time in history, Humanity is beginning to answer that question, not with resignation, but with technology. Planetary defense is a young field, but it is no longer fiction. In 2022, NASA's DART mission, the Double Asteroid Redirection Test, made history by colliding a spacecraft with a small asteroid called Dimorphos. The goal was simple yet profound: to see whether a deliberate impact could nudge an asteroid's orbit, even slightly. When the data arrived, the results were clear. The orbit of Dimorphos had been altered. Humanity had, for the first time, changed the path of a celestial body. This was not a solution, but a proof of concept. DART showed that deflection is possible, but also that it requires time, planning, and early warning. To shift an asteroid's orbit enough to save Earth, we must know about it years, ideally decades in advance. Without that warning, no amount of technology can help. The cosmos does not yield to last-minute solutions. That is why surveys matter. Instruments like NEO-Surveyor, scheduled for launch later this decade, are designed to expand our catalogue of near-Earth objects. Unlike ground-based telescopes, which struggle to see objects approaching from the direction of the Sun, NEO-Surveyor will operate in space, scanning infrared light to catch dark asteroids invisible to optical instruments. It is not glamorous work, but it is foundational. You cannot deflect what you do not detect. Europe too has joined the effort. The Hera mission, building on the results of DART, will revisit Dimorphos to study the crater left behind and refine our models of impact deflection. Each mission adds another piece to the puzzle, transforming planetary defense from theory into practice. And yet, for all this progress, the field is fragile. Funding waxes and wanes. Observatories compete for resources. Public attention drifts, pulled by nearer concerns. The truth is sobering. At present, we could not stop a comet like 3I Atlas if it were truly inbound. Its speed, its unpredictability, its interstellar origin, all would exceed our current capabilities. Still, the work has begun. The first steps have been taken. For the first time in history, we are no longer entirely helpless before the sky. For all the progress made with DART, Hera, and upcoming surveys like NEO-Surveyor, the reality is that planetary defense remains more aspiration than readiness. The challenge is not simply technical, but logistical and political. Deflection works only if we act early. The push of a spacecraft impact or the pull of a gravity tug is subtle. It takes years of orbital drift for that nudge to add up to a meaningful change. A rock discovered months before impact would leave us powerless, no matter how many rockets we launched. That is why early detection is the backbone of defense. At present, however, we have mapped only a fraction of the objects large enough to matter. Astronomers estimate that at least 25,000 near-Earth asteroids wider than 140 meters exist, and many remain unseen. Even when we do detect threats, the question of response is complex. A deflection mission must be launched quickly, but space missions take years to design and build. International cooperation would be required, because the consequences of failure or even success would be shared by all nations. The governance of planetary defense remains uncertain. Who decides when to act, who funds the mission, and who takes responsibility if something goes wrong? There are also limits to what deflection can achieve. Comets, especially those like 3I Atlas arriving on hyperbolic orbits from interstellar space, pose a unique challenge. They are fast, faint until close, and unpredictable in their behavior. A deflection mission designed for a slow-moving asteroid might be useless against a comet screaming in from the dark. In such cases, the only tool humanity truly has is time, and at present, we cannot guarantee we would have enough of it. Yet there is reason for optimism. The very fact that planetary defense is now discussed openly marks a profound change. For most of history, comets were portents, disasters to be feared but never confronted. Today, we speak of strategies, missions, and technologies. We are not yet ready, but we are no longer resigned. And perhaps that is the quiet gift of objects like 3I Atlas. They remind us of our vulnerability, but also of our ingenuity. They force us to prepare, even if preparation is incomplete. They turn abstract dangers into tangible motivations, urging us to keep watch, to build, to cooperate. When we step back, planetary defense feels less like an engineering problem and more like a measure of maturity. A species that can alter the course of an asteroid has taken its first steps towards stewardship of its own survival. And though our tools are crude, they represent the beginning of a long journey, one that will unfold over generations. Consider what we have already achieved. With DART, humanity demonstrated that intent can ripple outward into space, turning theory into action. With Hera, we will refine that knowledge, learning not only how much force is needed, but how materials respond, how fractures spread, how momentum transfers through fragile bodies. With Neo Surveyor, we will finally open our eyes wide enough to see what approaches from the shadows. Each step is small, but together they mark a threshold, the moment when we stop being passive, recipients of fate, and start becoming participants in our own cosmic story. Still, the gaps remain. We are not ready for fast interstellar comets, nor for surprise objects discovered too late. We lack a coordinated global system of response, one that could mobilize quickly across borders. We depend on fragile funding cycles, vulnerable to shifting priorities. For now, planetary defense is less a shield than a sketch of one. And yet, there is hope in the sketch. The very act of imagining defenses draws us closer to building them. Every mission, every survey, every simulation pushes us further from helplessness and closer to resilience. Like the slow accumulation of pebbles into a wall, the effort builds strength over time. Perhaps, one day, when another visitor like 3I Atlas sweeps into the solar system, we will not only watch, but act. We may intercept it, study it up close, even alter its course if need be. The tools are within reach, waiting for us to commit. For now, we live in the space between awe and preparation. We look up at the sky, grateful that this interstellar wanderer passed us by, and mindful that the next might not. We are not fully ready, but we are no longer blind, and that alone is a beginning worth treasuring. From questions of defense, we return to reflection. If 3I Atlas left us with uncertainties, it also left us with gifts, chemical clues, spectral lines, and a story written in motion. In the next section, we ask what this fragile traveller told us about the universe itself, not just about threats, but about origins, time, and the shared history of stars. When 3I Atlas first appeared in our telescopes, it seemed like a curiosity, a visitor whose odd chemistry and fragile structure raised more questions than answers. But as its brief story unfolded, another truth became clear. This comet was not simply a fleeting spectacle. It was a messenger from deep time, carrying within it the memory of a universe older than ourselves. Every comet is a kind of fossil, a remnant of the conditions in which it was born. Our own solar system's comets hold frozen records of the gases, dust, and ice that swirled around the sun 4.5 billion years ago. To study them is to glimpse the primordial recipe of our world. But 3I Atlas carried something rarer still, the record of a system not our own, a system whose birth may predate ours by billions of years. Astronomers speculated that its composition, rich in carbon dioxide and heavy metals like nickel, might trace back to regions of the galaxy very different from the quiet corner we inhabit today. Perhaps it formed in the turbulent outer edge of a massive star-forming cloud. Perhaps it was born near a star that lived fast and died young, scattering its fragments outward before collapsing into silence. The details are uncertain, but the implication is staggering. Within that fragile body lay chemistry from a time and place forever lost to us. Some estimates suggested that 3I Atlas could be as old as 7 billion years, nearly twice the age of Earth. If so, then it was a survivor of galactic epochs, drifting across space since long before our planet formed, long before the sun ignited. To hold that thought is to feel the scale of time expand beyond comprehension. While continents rose and fell, while species appeared and vanished, while humanity itself emerged and learned to gaze upward, this fragment of ice was already wandering, already making its slow approach to the faint point of light we call home. And when it finally arrived, what did it offer us? Not certainty, but perspective. Its green glow and fragile breakup were not just curiosities, they were reminders that the universe is old, that its stories stretch far beyond our lifetimes, and that sometimes those stories pass close enough for us to notice. In this way, 3I Atlas was not merely an object, it was a storyteller. Its tale was written in chemistry, in trajectory, in disintegration, and by reading it, we were reminded that the cosmos itself is a vast archive, each fragment carrying whispers of times and places we can never visit. To think of 3I Atlas as a 7-billion-year-old fossil is to reframe its brief visit in our skies. What looked like a fragile body unravelling was, in truth, the survivor of an almost unimaginable journey. It had crossed the gulfs between stars, drifted through the tidal arms of the Milky Way, and endured cosmic rays and collisions for longer than Earth itself has existed. Its disintegration was not a failure, but the natural end of an odyssey that had already lasted eons. Astronomers sometimes describe comets as time capsules. Within their frozen cores lie molecules formed in the earliest moments of a planetary system's life. Water, carbon compounds, dust grains older than the stars themselves. In 3I Atlas, those signatures were alien, not of our sun but of another. By studying its light, we were, in effect, examining the chemistry of a star system that no longer shares the sky with us. Perhaps its parent star has moved far away, hidden among billions of others. Perhaps it no longer exists at all. Yet here, in this fragile traveller, a record remained. The green glow that so captivated the public was part of that record. It was not just a curiosity, but a message in molecules, proof that different nurseries imprint their comets differently. The nickel lines, the carbon dioxide excess, the erratic outbursts, all of these were whispers from a distant birthplace, telling us that diversity in planetary systems is as rich as diversity in stars. And then there was the trajectory. Its hyperbolic orbit was not only a matter of geometry but of biography. To escape the gravity of its home star, some ancient event must have cast it outward with tremendous force. A planetary encounter, a stellar migration, perhaps even the explosion of a nearby supernova. Whatever the cause, that moment launched it into exile, beginning a journey that would eventually lead, by chance, to our skies. Its path was the residue of that ancient event, frozen in motion for billions of years. In this sense, 3I Atlas was more than an object of curiosity. It was evidence that the galaxy is not a set of isolated islands, but a place of exchange, of fragments passing between systems, carrying stories with them. The dust of one star becomes the visitor of another. The history of one world becomes, briefly, part of the history of ours. And so, in its fading light, we saw not just the end of a comet, but the continuation of a larger narrative that the universe itself is an archive, and every so often, a page drifts loose and lands within our reach. By the time 3I Atlas dissolved into fragments and haze, what it left behind was less material than meaning. The dust dispersed into the solar wind. The green glow faded. The nucleus, once intact, was gone, but the story remained a reminder that we had, for a brief season, been visited by a relic older than ourselves. To hold that in mind is to feel the scale of time expand. Earth's mountains erode and rise again. Civilizations bloom and vanish. Even stars live and die. Yet this comet, fragile as it was, endured all of it, drifting through epochs that defy imagination. Its final act in our skies was not tragedy, but testimony, proof that the galaxy remembers. The lesson it carried was simple but profound. The universe is not a distant stage upon which we are separate spectators. It is a web of exchanges, fragments, and encounters. We live not in isolation, but in a galaxy alive with motion, where the relics of other systems sometimes brush against our own. In studying 3i Atlas, we touched a piece of history written long before our planet was born. For scientists, this meant data spectra, orbits, models. For dreamers, it meant poetry, the vision of a traveller who wandered across time to meet us once, and never again. And for all of us, it meant perspective, that our lives, brief as they are, can still intersect with stories billions of years in the making. Perhaps, in the end, that is the greatest gift of visitors like 3i Atlas. They do not stay, they do not circle back, but in their passing, they remind us that the universe is vast, ancient, and full of memory, and that sometimes, if we are lucky, we get to read a single page of that endless book. From the perspective of science and time, we now turn inward, to the human side of the story. Why are we so captivated by such fleeting visitors? Why do comets like 3i Atlas stir not only scientific curiosity, but also awe, unease, and longing? In the next section, we explore the psychology of wonder and why we are drawn to mysteries that vanish as quickly as they appear. Why did 3i Atlas capture so much of our attention? After all, comets appear in our skies every few years, many brighter and longer lived. Yet something about this visitor seemed to strike deeper, lingering in the imagination long after its fragments had dispersed. Part of the answer lies in our ancient relationship with the sky. For thousands of years, comets were read as omens, unpredictable, untamed, appearing without warning against the steady background of stars. In a cosmos that otherwise seemed ordered and cyclical, comets were disruptions. They broke the pattern, and in doing so they forced people to ask what larger meaning might be hiding in the heavens. That instinct has never left us. Even today, with orbital mechanics charted and chemical spectra catalogued, the sudden glow of a comet still carries an echo of mystery. 3i Atlas, with its green halo and restless flares, looked less like a frozen rock and more like a ghost drifting across the night. It didn't behave according to plan, and in that unpredictability, we felt a spark of the unknown. Another part of its allure came from its identity as interstellar. To call something from beyond the solar system is to place it in a category almost mythic. Most celestial visitors are members of our own family asteroids, comets, and meteors tied to the Sunday. But 3i Atlas was a stranger, carrying the chemistry of another nursery, perhaps even older than Earth itself. To watch it was to brush against the wider galaxy, to sense that we are part of a network of stories larger than our own. The timing also mattered. In a world often crowded with human noise, news, conflict, distraction, here was a reminder of something that did not belong to us, that cared nothing for our schedules. The comet's appearance cut through the noise with the simplicity of light in the dark. Its brief season in our skies became a shared reference point, uniting scientists, poets, and casual skywatchers alike. And then there was the role of imagination. The more unpredictable the comet became, the more stories grew around it. Was it breaking apart? Was it a sign? Was it perhaps something more than natural? Online discussions flourished. Theories spun outward, blending science with myth. The uncertainty fueled not only curiosity but also creativity, a reminder that part of being human is to wonder, even wildly, when faced with the unknown. In all of this, 3i Atlas revealed something about us as much as about itself. We are drawn to the sky not only for knowledge, but for meaning. We crave both explanation and mystery. And when the universe sends us a fleeting visitor, we cannot help but turn it into a mirror, one that reflects our awe, our fears, and our longing to belong to something greater. The fascination with 3i Atlas was not only psychological, but also cultural. In the age of instant communication, its story spread with unusual speed. Amateur astronomers shared images of its green glow across social media, while news outlets amplified every flare and fragment into headlines. What might once have been a quiet observation for a handful of scientists became a global event, narrated in real time by thousands of voices. This constant flow of information shaped the way people experienced the comet. Each new report became a chapter in an unfolding drama. Discovery, brightening, strange chemistry, sudden dimming, final breakup. Audiences followed the narrative as though it were a serialized tale, each twist inviting new speculation. In many ways, the comet's unpredictability was perfect for this medium. It defied closure, keeping people checking back, waiting to see what happened next. Psychologists might say this reveals something fundamental about human attention. We are drawn not to certainty, but to tension. A comet that behaves exactly as predicted is admired briefly, then forgotten. A comet that flares unexpectedly, that challenges our models, that might conceal something extraordinary, captures imagination far longer. Uncertainty fuels curiosity. It keeps us leaning forward. There is also the deeper longing at play, our need to feel connected to the universe. In daily life, the cosmos can feel remote, abstract, reduced to numbers in textbooks or images on screens. But when a comet suddenly appears in our sky, visible to the naked eye or through a small telescope, the universe intrudes on the ordinary. It becomes personal. 3i Atlas was not just out there, in the realm of professional observatories. It was here, woven into the night above our homes. This intimacy is what transforms science into story. Facts alone tell us what the comet is. Experiences tell us what it means. A green haze above the horizon becomes not just carbon dioxide sublimating, but a lantern from another star system. A nucleus breaking apart becomes not just structural failure, but the embodiment of impermanence. Our minds lay a narrative onto data, and the result is awe. And finally, there is the timeless pull of rarity. Interstellar objects are not one in a million. They are rarer still, and for most of human history, invisible. To live in the moment when our instruments are finally sharp enough to catch them feels like a privilege. People sensed this, even if only intuitively. Watching 3i Atlas was not just astronomy, it was participation in a milestone of human discovery, a reminder that we are alive at a moment when the universe is opening new doors. When we ask why 3i Atlas drew us in, the answer is not found in the comet alone, but in us. Our fascination speaks to something ancient, something woven into the human condition. From the first time our ancestors looked upward, we have searched the sky for meaning. Stars became constellations, planets became gods, comets became omens. The heavens were never just distant lights, they were mirrors for our inner world. 3i Atlas reminded us that this impulse endures. Even in an age of spectrographs and orbital simulations, we still feel the need to story the sky. We turn chemical spectra into whispers from another world. We turn fragile fragmentation into a metaphor for mortality. We let an interstellar traveller carry not only dust and ice, but also our own longing for connection, for significance, for wonder. The comet's fleeting nature made that longing sharper. It was here and gone in a matter of months. To know that we would never see it again gave its light a rare poignancy. Like a song heard only once, or a stranger glimpsed briefly and never met again, its beauty was magnified by its transience. We were compelled to notice, to remember, because we knew the moment would not return. This sense of impermanence resonates deeply with us. Life itself is fleeting. Generations rise and fall, civilizations flourish and fade. Against this backdrop, a comet like 3i Atlas becomes a cosmic reflection of our own condition. Its passage reassures us that transience is not failure, but part of the story that even the briefest lights can leave a lasting mark. In the end, the comet's greatest gift was not data or spectacle, but perspective. It reminded us that the universe is vast and alive, that we are participants in its drama, and that meaning is not always found in permanence. Sometimes it is found in the brief encounter, the flicker of light, the moment we carry forward in memory. And perhaps that is why we were so captivated. Not because the comet demanded it, but because we needed it, a reminder of mystery, a taste of connection, a fleeting glimpse of eternity passing close enough to touch. From the human heart we return now to the sky itself. 3i Atlas has taught us about chemistry, fragility, and wonder. But perhaps its most enduring lesson is simply this, that the universe is always moving, always scattering pieces of itself across time. In the next and final section, we will reflect on its departure, a wind down as the traveller drifts away, leaving us once more beneath the quiet stars. Now, as we lean back from the story of 3i Atlas, we find ourselves beneath a quieter sky. The green glow has faded, the fragments have drifted beyond the reach of our telescopes. The visitor is gone, and the night is once again filled only with the familiar constellations. There is a bittersweet rhythm to this ending. For months, the comet gave us something rare, a chance to watch the universe write a fleeting chapter in real time. We followed its light as it flared and dimmed, imagined its journey from distant stars, and wondered at the fragility of its body. And then, as suddenly as it came, it slipped away. But absence is its own gift. In the quiet left behind, we feel the echo of perspective. To have seen 3i Atlas at all was a privilege, a reminder that we live in a galaxy alive, with motion, where ancient travellers sometimes brush past our small world. The comet's departure leaves us not diminished, but enriched, carrying a sense of connection to something larger and older than ourselves. This is the nature of the cosmos. Visitors arrive, they pass, they do not return. Yet in their passing they remind us of continuity, of stars that burn for billions of years, of planets that spin faithfully, of comets that wander endlessly. Our role is not to hold them, but to notice them, to weave them into our story, and to let their memory shape our sense of wonder. And so, as 3i Atlas recedes into the dark, we remain here beneath the same sky, with the same questions. What else drifts between the stars? Who or what might follow? And how will we feel when the next green lantern appears on the horizon, glowing briefly before it, too, dissolves? Imagine the path of 3i Atlas now no longer visible, but still gliding outward, away from the Sunday. Its fragments drift like pale ashes, carried by the solar wind, dispersing into the galactic sea. There is no destination waiting, no orbit to return to, only motion, endless and indifferent, carrying it into deeper silence. And yet, in that silence, we find meaning. For the comet's farewell mirrors something deeply human, the way encounters in life come and go, leaving impressions that linger even after the moment has passed. Just as we remember a fleeting kindness or a face glimpsed only once, so too will we remember this comet, not because it stayed, but because it didn't. Its impermanence sharpened our attention, made us pause, made us look up. The night sky has always been a canvas for reflection. Long before we knew the word interstellar, our ancestors told stories of passing comets as warnings, blessings, or signs of change. Tonight, we continue that tradition in a gentler way. 3i Atlas may not have been a sign, but it was a reminder that we live in a universe vast enough to send us visitors, and brief enough that we must cherish them. And so, the green glow fades. The news cycle shifts. Our telescopes turn to other targets. But somewhere in the back of our minds, we keep the image, a fragile traveller unravelling in the sunlight, leaving nothing behind but dust and memory. A symbol, perhaps, of how even the most fragile things can illuminate the dark. And now, as our story closes, the comet has become memory. 3i Atlas is gone, a traveller who visited once, burned briefly, and departed forever. What remains is not its dust, scattered far beyond our reach, but the way it made us feel, curious, humbled, and strangely comforted. Perhaps that is the quiet legacy of visitors like this. They remind us that we are not alone in motion. Just as stars drift across the galaxy, just as comets wander through the void, so too do we drift through time, our lives brief arcs against an infinite backdrop. The cosmos does not pause for us, yet it sometimes offers these fleeting intersections, moments where the vastness leans close enough for us to notice. As you lie beneath your own sky tonight, maybe you'll glance upward and remember, the stars are steady, but the universe is restless, forever sending us guests we will meet only once. 3i Atlas was one such guest. Its path brushed ours, its light touched our nights, and now it is gone. But the wonder it stirred remains. And that, perhaps, is the true gift. Not certainty, not permanence, but the invitation to keep wondering, to let mystery soften our thoughts, to drift into sleep with the comfort that we are part of something vast, ancient, and still unfolding. So, close your eyes if you wish. The traveller has passed, the sky is quiet again, and tomorrow night, and every night after, it will still be waiting vast, dark, and full of stories yet to be told.